Alright, so after watching that video, let's go ahead and recap what we just learned. So 1 mole of any substance is equal to its molar mass. And the molar mass is taken from the periodic table. So this statement that 1 mole of any substance is equal to its molar mass can be represented as a conversion factor that you can see right here, or you can see its reciprocal, which is stated right there. So also, B, 1 mole of any substance contains 6.02 times 10 to the 23rd particles. And a particle is defined as an atom if you're talking about an element, or a particle can be defined as a molecule if you're talking about a compound. To be successful at solving dimensional analysis calculations in the stoichiometry unit, there are 6 steps that you should do. And you can find these 6 steps written out in the Google slide presentation. So let's just go ahead and fill out our notes section. So the first step is to write your given from the problem. Your second step is going to be to choose the appropriate conversion factor. The third step is to make sure the unit of the given and the unit in the denominator of the conversion factor are alike. Your fourth step is going to be to cancel your like units. Your fifth step will be to circle the remaining unit. And your sixth is to complete the calculation. And I'm going to add on to this. And please remember to have a final answer with units. It's always important to have a final answer that has your units. Okay, so let's go ahead and apply what we have just taken notes on to some dimensional analysis problems that deal with a mole and its molar mass. So application problem number 1 says how much mass is in 6 moles of carbon? So step number 1 says to write your given. Step number 2 says to choose the appropriate conversion factor. So the conversion factor I'm going to choose is the one that has moles of carbon in the denominator, and it'll have grams of carbon in the numerator. And I chose this conversion factor because the denominator of the conversion factor is the same, has the same units as the units of the given, which is what step 3 is reminding you to do, to make sure the units of the given and the unit in the denominator are alike. And so step 4, cancel your like units. Step 5 is to circle my remaining unit. And then step 6 to complete the calculation with the appropriate units. So let's pause for a moment and back up. What goes here the number that goes in this little blank, the grams of carbon, is going to be its molar mass, and the molar mass I find from the periodic table. So I'll get my periodic table and I'll look for carbon atomic number 6, and it has a mass of 12.011. So into my calculator I'll type in 6 times 12.011 divided by 1, which is simply just itself. So my answer is going to come out to be 72.06 grams of carbon. So what this means is that if you had 6 moles of carbon, it will have a total mass of 72.06 grams. Okay, so problem number 2 says how much mass does 8.5 moles of zinc have? So I'm going to go ahead and write my given 8.5 moles of zinc. I'm going to choose my appropriate conversion factor, which is going to be the molar mass of zinc. So I'm going to have to look at the periodic table, and I'll say that zinc's mass is 65.41 grams. So the molar mass of zinc is equal to 1 mole of zinc. And just as a reminder, I know that the 1 mole of zinc goes in the denominator because the units in the denominator have to cancel the units of the given. So that's how I know I've set this problem up correctly. I'm going to go ahead and circle my remaining units, which is grams of zinc. And then now we're going to carry out the calculation. So into my calculator, I'll put 8.5 times 65.41, and then divided by 1, which is just itself. So my answer comes out to be 555.985 grams of zinc. Okay, problem number 3. How much mass does 0.35 mole of CuCl2 have? So first of all, we are talking about the compound CuCl2. So in order to find a molar mass, we're going to have to look at the periodic table, find Cu, its mass, and we're going to have to add that to the mass of 2 chlorines. So just a little side note, the molar mass of CuCl2 is 134.45 grams. Okay, so moving on. Let's go ahead and start this. Let's write our given 0.35 moles of CuCl2 we're going to choose the appropriate conversion factor, which again is going to be the molar mass of CuCl2 So the molar mass of CuCl2, 134.45 grams, is equal to 1 mole of CuCl2. I'm going to go ahead and cancel the units of my given and the units in the denominator. circle my remaining units, and then I'm going to carry out the calculation. So into my calculator, I'll type in 0.35 times 134.45 divided by 1, which is just simply itself. And my answer will be 47.1 grams of CuCl2. Okay, so problem number 4 is a little bit different. Okay, and what I mean by that is that it reads 219 grams of FeSO4 are how many moles? So this problem is asking us to convert from grams to moles, whereas the other ones have been asking us to convert from moles to grams. But I'm going to use my 6 steps for solving these dimensional analysis problems. So I'm going to write my given, which is 219 grams of the FeSO4. And now I'm going to choose the appropriate conversion factor. So for my conversion factor, I know that the units of my given have to be in the denominator of the conversion factor. And so grams of FeSO4 have to be right here. So that means that the 1 mole of FeSO4 is going to be in this numerator. So we're going to have to find the molar mass of FeSO4, which is 151.908. And if you're wondering how I got 151.908, I looked at my periodic table, I took the mass of 1 Fe, and I added it to the mass of 1 sulfur, and then I added that to the mass of 4 oxygens. Okay, so let's cancel out our like units. So the units of my given and the units in the denominator, circle my remaining units. So into my calculator, I'm going to carry out the calculation by punching in 219 times 1 and then divide that by 151.908. And the answer comes out to be 1.44 moles of FeSO4. So next, the last practice application is going to be number 5, which says 219 grams of calcium nitrate are how many moles? So let's write our given. 219 grams of the calcium nitrate. And this is the same amount of grams as problem number 4, but it's a different compound. So that's why it's really important to always indicate which compound or which element you're doing these problems about. All right, so write my given, choose my appropriate conversion factor. So 1 mole of calcium nitrate in the numerator, and then the molar mass of calcium nitrate is going to go down here in the denominator. So I knew that the grams of calcium nitrate, the molar mass, went in the denominator because the units of my given was grams of calcium nitrate, and what's in the denominator has to be the same. And also, if you're wondering how I found the molar mass of calcium nitrate, I went to my periodic table, I looked up calcium, I added it to 2 nitrogens and to 6 oxygens. So remember, guys, that 2, that subscript 2 on the outside of the parentheses around that nitrate, you distribute that 2 in. So you have calcium nitrate has 1 calcium atom, 2 nitrogen atoms, and 6 oxygen atoms. Okay, so I've crossed off my similar units, and then I'm going to circle my remaining just to make sure I've done this correctly. And then into my calculator, I'm going to punch in 219 times 1, which will just be itself. And I'm going to divide that by 164.0878. And I will get an answer of 1.33 moles of calcium nitrate. Okay, great. So your job is to, on this next page, this practice session, problem number 6 through 10. So these 5 problems. And I just want to make sure to note that number 10 is only for the honors sections. All right.